Hi everyone, this is Deepti. In the last video of surface chemistry, I have discussed about factor affecting adsorption. And today's video, I am going to discuss about the Freundlich adsorption isotherm, which is very important concept in adsorption, and it is very tricky to understand this concept. So watch my video till the end without skipping. Only then you will be able to answer any question regarding this concept. And also, at the end of this video, I am going to ask some questions which will be helpful for your CET and NEET examination. So, stay tuned and be conscious while watching my video. So, what are you waiting for? Let's start today's session. Before that, if you're not yet subscribed to our channel, please subscribe. To get the regular notification, click on the bell button. Okay, let's start. Welcome to Light Up. Adsorption isotherm. So, adsorption means accumulation of gas molecules on the surface of the material is called adsorption. Isotherm. Iso means same or constant. Therm means temperature. At constant temperature, how the adsorption taking place is discussed in adsorption isotherm. That is, the variation in the amount of gas adsorbed by the adsorbent with pressure at constant temperature can be expressed by means of a curve is called adsorption isotherm. Under this, you are going to learn about the Freundlich adsorption isotherm. Freundlich adsorption isotherm. Here, Freundlich is a scientist who successfully explained how the extent of gas adsorbed by varying pressure. How gas adsorbed by varying pressure. He explained by using a graph. Where pressure is taken along x-axis and extent of adsorption is taken along y-axis. He said that as the pressure increases, the adsorption also increases. As the pressure increases, adsorption also increases. He also gave the equation called Freundlich adsorption equation. It is Freundlich equation. X by m is directly proportional to P. As the pressure increases, the extent of adsorption increases. He gave the equation X by m is directly proportional to P to the power of n. That is, X by m is equal to K, proportionality constant, into P to the power of n, where n is always greater than 1. This is called the Freundlich equation. Let us take it as equation 1. Equation 1. So, this equation is important. X by m is equal to K into P to the power of 1 by n. Here, X indicates mass of gas adsorbed. Mass of gas adsorbed on the surface of the material, and m indicates mass of adsorbent. If I take a material, so material mass, that is m, and the gas on the surface, it is taken as x, and then so P means pressure, and then K and N are constant. K and N are constant. The value of K and N, the value of K and N depends on adsorbate and adsorbent. Nature of adsorbate and adsorbent. So nature of adsorbate and adsorbent, the value of K and N depends. That means highly liquefiable gas, that is highly liquefiable gas are highly adsorbed. To know more about liquefiable gas, watch my previous video, that is about the characteristics of physisorption. You get link in the description box. Okay then, the value of 1 by n lies between 0 and 1. Again, the value of 1 by n is very important. It lies between 0 and 1. This 0 and 1 depends on the pressure. As the pressure varies, the value varies. Let's see this variation one by one by using the graph. Again, I am drawing the graph, that is x by m versus pressure. So by using this graph, let us know the value of 1 by n. You can observe this graph. As the pressure increases, x by m, extent of adsorption increases. The straight line. I am taking this as one part, and then you can observe the curve. I am taking this as the second part, and the final, as the pressure increases, the graph remains same, become constant. From here to here, it is the third part. I am going to discuss this graph in three parts, that is in three cases. Let's see one by one. And the first case, at low pressure, the value of 1 by n becomes 1. At low pressure, the value of 1 by n becomes 1. This is why, because as the pressure increases, extent of adsorption increases. You can see from the origin, it is increases in a straight line. Therefore, the extent of adsorption depends upon the pressure. Let us apply this 1 by n is equal to 1 value in equation 1. Equation 1, that is x by m into k into p to the power of 1 by n. Freundlich equation. To this 1 by n, let us apply the value. X by m is equal to k into p to the power of 1. That means x by m is equal to k to the power of k into p to the power of 1 means it is p. This is the equation. You can see here, you can observe here x by m depends upon pressure, which is directly proportional to pressure. Therefore, 1 by n value becomes 1 at low pressure. This is the first case. Next, let us move on to the second case. At high pressure. At high pressure, the 1 by n value becomes 0. 1 by n value becomes 0. Why it becomes 0? See here, as the pressure increases, the extent of adsorption remains same, remains constant. There is no variation, there is no increase or decrease in adsorption. The extent of adsorption remains constant, remains same. Therefore, what we can say that the extent of adsorption is not depending on pressure. The extent of adsorption does not depend on pressure here. Therefore, 1 by n value becomes 0. Let us apply this value in equation 1, that is x by m is equal to k into p to the power of 1 by n. So, I am applying. So, p to the power of 0. That is x by m, it is equal to k into p to the power of 0 means 1. Therefore, the equation becomes x by m is equal to k. X by m, that is equal to k. What it indicates means the extent of adsorption does not depend on pressure. It becomes constant. Therefore, 1 by n value is 0 at high pressure. First case, at low temperature it is 1 and at high temperature it is 0. Again, there is one more case, the third case. Third case, we call this curve as intermediate pressure. It is low pressure and high pressure. Here intermediate pressure. At intermediate pressure, the value of 1 by n lies between 0 and 1. That means it may be 0.1, 0.5, like that. Therefore, we write it as 1 by n is greater than 0 and lesser than 1. Therefore, the equation is x by m is equal to k into p to the power of 1 by n. Because 1 by n value lies between 0 and 1, it may be 0.1, 0.2, 0.3, 0.4, 0.5. It is a fraction. So, the equation will be like this. X by m is equal to k into p to the power of 1 by n. These are the 4 cases which we are going to study in this graph by using this graph. Here, we should observe that at low pressure, the value of 1 by n is 1 and the graph starts from the origin and moving upward in a straight line. And again, at high pressure, the extent of adsorption graph is parallel to x-axis. In intermediate pressure, you can observe the curve traveling. These are the 3 cases which we are going to study in Freundlich Adsorption Isotherm graph. This is one kind of a graph at constant temperature. The extent of adsorption varies with pressure. By varying the temperature, you get one more graph, that is, let us vary temperature. So, in the first graph, what we have observed that as the extent of adsorption increases, that means as the pressure increases, the extent of adsorption increases, which is directly proportional. If we increase the temperature, what will be the extent of adsorption? The extent of adsorption is inversely proportional. Therefore, the extent of adsorption decreases. As the pressure increases, extent of adsorption increases. As the temperature increases, extent of adsorption decreases. Let us see the graph. Along x-axis, I am taking pressure, and along y-axis, x by m, that is extent of adsorption. As the pressure increases, extent of adsorption increases. Let me take 3 cases, that is 3 temperature, that is 195 Kelvin, 244 Kelvin, and the third temperature is 273 Kelvin. Let us draw the graph for these temperatures. For 195 Kelvin, the graph obtained is as the pressure increases, extent of adsorption also increases. This is at 195 Kelvin. Let's move on to the second one, that is 244 Kelvin. At 244 Kelvin, what will be the adsorption? The adsorption decreases. Therefore, the graph will be like this. At 244 Kelvin, as the pressure increases, adsorption increases, but as the temperature increases, adsorption decreases. At 273 Kelvin, again the temperature, adsorption decreases. You can observe that as the temperature increases, adsorption decreases. This is the second graph, which is also called as adsorption isotherm graph. In the first equation, that is in equation 1, I have said that K and N values are constant and it depends on the nature of adsorbate and adsorbent. This value, the K and N value, can be calculated by using equation 1. K and N value can be calculated using log for equation 1. So equation 1 is a Freundlich adsorption equation. Let us take that equation now. X by M, that is equal to K into P to the power of 1 by N. This I mentioned as equation 1. Now let us apply logarithm log on both sides for this equation. So log X by M, that is equal to log K into P to the power of 1 by N. Before simplifying this logarithm equation, let us know the indices first. Logarithm indices, that is log M into N is equal to log M plus N, log M plus log N. Then log A to the power of N can be written as M into logarithm A. This is the indices. Using these indices, let us simplify this equation. So log X by M is equal to, so log K into P is in the form of log M into N. Therefore, we can write it as log K plus log P to the power of 1 by N. And again, this log P to the power of 1 by N is in the form of log A to the power of M. So, in the next step, we can write it as X by M is equal to log K plus log P to the power of N can be written as 1 by N log P. This we call it as equation 2. Equation 2. By using this equation 2, we can draw the graph, and by that graph, we can identify K and N value. We can calculate both K and N value. So, let's draw graph by using the second equation. So, I am taking the second equation, that is log X by M is equal to log K plus 1 by N log P. This is called as equation 2. So, how to draw the graph by using this equation? Let us compare this equation with the straight line equation. That is straight line equation y is equal to mx plus c. Y is equal to mx plus c. Let us apply this equation to the equation 2. So, here y, mx, there is two terms. You have to observe and then we have to apply this. So, log x by m is taken as y, and then here single term, here there are two terms. So, we take it as mx plus c. Y is equal to mx plus c. How to draw the graph now? Let us take x-axis and y-axis. Here, along y-axis, we can write log x by m. Y indicates log x by m, y-axis, and x-axis. There is two terms here. So, x along x-axis, we can write a log p, and m indicates here slope and c indicates intercept. Intercept, that is constant. So, here m indicating 1 by n with a positive sign, This positive sign indicates that the slope is positive, which is moving upward direction. If the slope shows negative sign, then the graph shows negative slope and the line will go downwards. The graph will be like this if we get the negative slope. If we get the positive slope, then the graph will be upward direction, moving upward direction. Okay. So therefore, here we get the positive slope. Slope is 1 by n. Then the intercept. Intercept we are taking as log k. Log k. Here, the intercept has some value, that is log k. Therefore, the graph does not start from the origin. If the intercept has some value, the graph does not start from the origin. It starts above the origin. Therefore, the graph will be like this. Positive slope plus 1 by n. So, the graph will be like this. Slope is equal to 1 by n. And intercept, that is log k, called as intercept. The distance the distance from the origin till the graph starts. From here to here, we get the value of log k. By using this graph, we can identify or we can calculate n value and k value. N and k value. So, these are the three kinds of graph what we have discussed today. This is all about today's video. Freundlich adsorption isotherm with graph. How the extent of adsorption vary with pressure at constant temperature. If you have any doubts regarding this concept, you can comment below. We have some questions regarding this concept which is helpful for CET and NEET examination. The first question is Freundlich adsorption isotherm is given by the expression x by m is equal to k into p to the power of 1 by n. Which of the following conclusion can be drawn from the expression? You have to answer this. There is 4 options. When n is equal to 0, plot of x by m versus p is a curve. When 1 by n is equal to 0, the adsorption is independent of pressure. Third option is when 1 by n is equal to 0, the adsorption is directly proportional to the pressure. And option 4, that is when n is equal to 0, the plot of x by m versus pressure graph is parallel to x-axis. You have to answer these questions in the comment box. The second one is how extent of adsorption related to pressure when 1 by n is equal to 0. So, third one, how temperature is related to extent of adsorption. And the fourth question is, in Freundlich adsorption isotherm, the value of 1 by n is. Answer these questions. Take out this screenshot of this video and answer this question in the comment box. Okay. If you like my video, please like, share and subscribe my channel. Thank you.